All right, we're going to start looking at chapter 4, which is titled Collecting Data. If we don't gather data in such a way that's reliable, then what we have is worthless. Our idea or what we're going to be concentrating on with collecting data, and the purpose of this is we want to draw an inference, or we want to come to a conclusion about some population. Well, if the data that we're looking at is bad data, then our conclusion is going to be worthless. So the whole idea, we're going to look at surveys, sampling, and experiments through chapter 4. How do we gather good data is going to be our first task. So we need to have the language once again. What are we talking about? What are we trying to do? Well, we're trying to answer a question about an entire population from a small sample. The population is the entire group of individuals that we want information about. And the sample is the part of that group or the part of that population that we actually collect the data from. Census is a term that we've heard quite frequently lately because it just came about, where we took the census of the United States. And what is a census? That's when we collect data from every single individual in the population. If we were able to conduct a census, there would be no need for us to do any sort of tests or any sort of inference, because we would know the true answer of the entire population. A census works well if the population of interest is very small. We can gather the data and find out what we want to find out. However, if the population is very large, say the entire United States, or everybody in the world, or all teenagers, or all college students, or any population that's too large for us to reasonably contact every individual to gather data from, we're going to have to take a sample, which is part of the population or a subset of the individuals in the population. For example, what proportion or what percent of all teenagers in the United States text while they drive? Well, contacting every teenager in the United States is just unreasonable, something that we wouldn't be able to do. We would not be able to collect a census of teenagers texting while driving habits. Therefore, we would need to take a sample of all teenagers in the United States. Well, how we take that sample is going to be very important. A sample survey is a study that we do that collects data from the sample of a population. So a sample survey, you see those all the time. Retailers are really big on that right now. You go to Jack in the Box, they say, hey, go online, we'll give you $5 off if you take our survey. Anywhere you go, they're asking you for a survey. So it's just a list of questions, or maybe it's a phone survey. You've probably all had somebody call you and say, hey, can you take a few minutes and answer my questions? And what do we all do? Click, hang up on them, right? So a survey is just somebody asking questions at random to gather information about an entire population. Now, a sample survey means that we're not going to survey the entire population, and we would call that a census. We are going to sample a portion of the population, or survey a sample, which is a part of the population. There's some really bad ways to sample. One of them is called a convenience sample. For example, I would like to know what percent of high school students spent at least 5 hours on homework last week. So if I were to ask every student in my class, how many hours of homework did you do last week? That would not be a good representation of the entire population. Remember, in a sampling method, we're trying to get an answer for everybody that falls in that population. And if I'm looking at high school students and I want to know on average how many hours per week do they spend doing homework, if I were to just ask everybody in this AP stats course, that would be a convenient sample. I would be asking all of you guys because it was convenient. You were easy to reach. You were right here in front of me. You were already here. I asked you, how many hours a week did you spend in homework, and recorded it? Now, that would not be a good representation of all high school students. If I just sampled AP students or students in AP statistics, the value or the average number of hours spent on homework last week would probably be much higher than the true population of all high school students. So in a convenience sample, oftentimes or most of the time, the data is not going to be reliable. Why would someone do a convenience sample? Because the word convenience, it's easy. They're right there, easy to reach. However, it's a waste of your time because it's not going to tell us about the entire population as a whole. Another bad sampling method, one that does not work very well, is voluntary response sample. That's when people choose themselves to answer the questions or to be part of the sample. Oftentimes, this is done on the internet or over the radio. They'll have a phone in or a response on a website where they say, well, how do you feel about a certain topic? And people would choose themselves to go there and answer the question. Now, voluntary response samples usually will give us people with a strong negative opinion. People who feel really strong about a certain subject were the only people who would choose themselves to come be a part of the sample. For example, what do you think about this food that the school serves to us? Come by my room at lunch and tell me your thoughts on what you think about the food at the school. Well, the only people who would take the time to come by and tell me about it are the people who feel really strongly, oh man, our food sucks. This is the worst stuff we've ever had. So if you think the food's okay, you're not going to go out of your way to come up to somebody's classroom and tell them your opinion on it. So voluntary response sample, people who choose themselves to be a part of the sample. Convenience sample are ones that we choose because they're easy to reach. Both of these are going to give us bad data. If the data that we're gathering and collecting is not representative of the entire population, then we've just wasted our time. Okay? Both of these would lead to a bias. Okay? A bias is when certain answers are systematically favored, or as the book says, bias is very likely to underestimate or overestimate the value of the true population. Remember, what we're trying to do here is from a small sample, we're trying to answer a question about the entire population. So a bias is when we have data that is not representative of the entire population. Random sampling. Now we're going to take a look at some types of methods that would give us reliable data. Again, we need reliable data so that we can answer the question from a sample about the entire population. This is going to be a big theme throughout the rest of this year. Once we get into inference and significance tests and confidence intervals, this is what we're trying to do. We're trying to take a very small sample. For example, how do they know that 70% of the population is going to vote for the Republican next year or going to vote Democrat next year? They don't ask everybody in the population. They gather data through random sampling methods that are reliable, in which from that small sample, then they can tell you the answer of the larger population. So random sampling doesn't mean random or haphazard or, dude, that was so random. That's not what we mean in statistics by random sampling. Okay. Random sampling just means that we use chance in order to choose who's in the sample. Okay. Think of putting everybody's name in a hat and mixing the pieces of paper up and pulling a name out of a hat. That would be random sampling. That would work fine if there was 10, 15, 20, 30 people. But if we're trying to do a random sample of thousands or hundreds of thousands of people, obviously we would not be able to put them all into a hat to choose which ones we would gather data from. Okay. So very, very important in our sampling method that it's random in some fashion. The most important one by far, the one that we will use the most, is what we're going to call a simple random sample. We're going to talk about this so much that we're going to abbreviate it all year. We're just going to refer to it as an SRS for simple random sample. Okay. And in SRS, every single individual in the population and every single group of individuals in the population will have an equally likely chance of being chosen. So for example, If we wanted to find out about what percent of teenagers text while they drive, and we were going to take a true SRS, we would have to randomly select from every single teenager in the United States. Every single one of them would have to have an equally likely chance of being part of our sample. Remember, if we were to sample every teenager in the United States, we would call it a census. A census is not something that we're going to use very often, if at all, in real life statistics. Because if we knew the answer, why would we be doing a study to find the answer? Okay, so an SRS is chosen in such a way that every single individual has the equally likely chance of being part of this sample. An SRS is a great way to sample. However, sometimes an SRS might not be the best way. In certain cases, for example, I want to know on average, how long does it take a teenager to do their hair in the morning before school? Well, if I took an SRS of students from our school, it's possible, since everybody has an equally likely chance of being chosen. It's possible that I chose the sample, which were all young men with shaved heads. Well, they would tell me on average, I spend 0 minutes every morning doing my hair. That's not really a true representation of all students at our school. Or the opposite, I could choose a sample through an SRS that were 10 female students who all had long hair. Well, that would take them half hour each morning to do their hair before they came to school. And then I would say, oh, the true mean amount of time a high school student spends on their hair in the morning is 30 minutes, which isn't truly a good representation of the entire population. So we need to be able to deal with that. In this situation, if I'm looking at how long does it take to do your hair in the morning, I can see before I go out and gather the data that this population is different in some way that's going to be important to my results. And those groups would be called strata. So strata are the groups of individuals who have a characteristic that we know going in may be important to our study. So in this case, rather than taking an SRS, I might want to take a stratified random sample instead. And a stratified random sample, we would look at the groups and then take a separate SRS within each group. So for example, I would have male and female. I would take an SRS of 5 males, an SRS of 5 females, bring them together to get my total sample of 10 students. That way I have a better representation of the entire population. An SRS could work, but going in, I know, you know what, there's a difference between males and females. So I want to have an equal amount of each in my sample. Therefore, it's a better representation of the entire population of students at our school. So again, SRS is the way to go unless we know there's a difference in the population that may be important to our results. Okay. Another type of sampling method that's used quite frequently is cluster sampling. Okay. A cluster is a large group of individuals within the population that are located near each other. Cluster sampling is used when the populations are very, 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 very large. So let's say at our high school, we have 3,000 students. Okay. So for this cluster sample at our school, we have 3,000 students. And I want to choose 50 of them at random. Well, I could take an SRS of 50 of these 3,000 students. But what a cluster sample does is it numbers the students probably alphabetically, but us as the researchers get to decide. We'll label these students from 0001 to 3,000. We have 3,000 students at our school. And if I want to take 50 of them, then I would take 1, 2, 3, all the way down to 50. This would be cluster number 1. And then 51 all the way down to 100. This would be cluster number 2. Then I would randomly select one cluster and use all 50 individuals within that cluster. So these methods are reliable. By far, the best method of sampling is an SRS, unless we know that within the population there is a difference that would be very important to our results. So, reliable sampling methods. SRS, stratified, cluster, all of those will give us results that are reliable or a good representation of the entire population. Remember, we're trying to use a small sample to answer the question about the large population. Well, how would we choose this SRS or stratified or cluster? How do we make sure that it is random? So the first thing we're going to do is label each individual in the population numerically from 1 to however many there are. Just like on the last page, we said that there were, if we were looking at a high school that had 3,000 students, we would label student number 1, student number 2, all the way to student number 3,000. And then there's two different ways that we could randomly select our sample. So how would we choose these students that way? I don't want to write out 3,000 little numbers on a piece of paper and put them in a hat. I have to have a really big head to fit all those numbers in one hat. Instead, what we're going to do is use technology or something called a random digit table. Okay, so each individual here would have an equally likely chance. Our calculator has a random digit table built in. In this random digit table, which you can see here, these numbers 1, 9, 2, 2, 3, and so on are randomly selected between the digits from 0 to 9. So we put the numbers 0 through 9 in a hat. We drew one of them, and the first number was a 1. We put the 1 back in the hat. We mixed them up. We drew again. The next number was a 9. And then we kept doing that. The next number was a 2. And we threw it back in. Oh, we got a 2 again. So this would give us a random set of values, or a what we will call the random digit table. The calculator has one of these tables built into its brain. So the calculator also has a random digit table. So let's say I want to choose 10 students out of the 3,000 from our school. And I want to do a true SRS because I want to see what percent of these students, of the students at our school, text while they're driving. So what I would do here is grab my calculator, and it has this random digit table built into it. Okay. So if I'm going to randomly choose 3,000 students from, or 10 students from the 3,000 students at our school. So the population of interest is the students that go to our school, 3,000. The sample is the 10 students that we're going to choose for our sample. From those 10 students, we are going to try to answer a question about all 3,000. So how would we generate random digits, or how would I select these 10 students? I would label the students starting with the first student alphabetically would be student number 1, to the last student alphabetically would be student number 3,000. All right, so let's pick these 10 students. Let's let the calculator do the work for us. So we're going to choose a random integers. So if we go into math, probability, and number 5 is rand int. What we're going to tell the calculator to choose 10 random numbers between 1, it's the smallest number we wanted to choose from, to 3,000. And then we need to tell the calculator, hey, how many numbers do you want us to pick? Oh, we want 10 students. Okay. And then paste. If you do not have a 84 and you're using a TI-83, you would type in rand int parentheses 1, 3,000, 10. So this is going to give us at random 10 students. And you can see those 10 students. We would choose student 2,831. So that would probably be somebody with a last name of V. It might be Johnny Vasquez or something like that. 2831. Remember these 3,000 students. There I go touching the screen again with the calculator. Those 3,000 students, those numbers would be listed next to their names. All right, so I could just scroll through here to see which 10 students were chosen. Now, again, the population of interest is the 3,000 students at our school. We would label them from 1 to 3,000. So I'd have to go through my list and say, oh, I need student number 2,202. I need student number 132. And that would be a SRS of 10 students from our school. Now, if I want to choose an SRS without using technology, and I want to use the random digit table, or in our book, it's going to be called Table D. This random digit table has been made from a calculator such as the one that we just used, and then the numbers have all been written out in a list. So if I want to choose 10 students out of here, it's different if we use the random digit table. I can't label them 1 to 3,000. If we did, I could look at student, the first number is number 1. Oh, I picked student number 1. Well, that's not an SRS, because if I'm looking at one digit at a time, there's no way student 3,000 could have been chosen, because I'm only looking at one digit at a time. Only the students labeled 1 through 10 would have a chance of being chosen. Therefore, every student has to be labeled with the same number of digits. So this method up top would work fine if we're using technology. The calculator understands when we say 1 to 3,000. But this random digit table, we would have to label the students from 0001 to 3,000. So then, therefore, I would have to look at 4 digits at a time. So the first student I would choose would be student 1922. The next student I choose would be student 3,950. But we only go up to 3,000. So I would just ignore that student because it's not part of the population. The next student would be student number 0340. Oh, that's student 340. So now I have 2 of my 10. So 0340. The next 4 digits is 5756. Well, I don't go up that high. So that's not part of my sample. The next student would be student number 2871. I would continue through this random digit table. If I did not get all 10 by the time I got to the end, I would jump down to line 102 and continue the process until I'd found all 10 individuals. So this would constitute my sample, or my SRS, my simple random sample of 10 students from our high school of size 3,000. Now, how we go about labeling the students is going to be very important. The other thing that I failed to mention is, let's say I'm going through the table and I find student 1,922, and then again I found student 1,922. Well, you can't use the same individual twice. So any digits that come up in this random digit table that are not within the scope of our label or our repeats, we just skip and keep going until we found all the individuals. Most of the time, though, you would probably use technology since it's so much faster. However, on the AP test, they like to give you a random digit table just to see if you understand the process and the labeling process of the individuals within the sample.